So this is the MATLAB project, which is basically the simulation of standing waves in an open and closed tubes using the MATLAB. Basically, in this project, I have just performed the standing sound waves formed in open and closed tubes using MATLAB. So standing waves occur due to interference of two identical waves traveling in opposite directions, like creating stationary points of zero displacement nodes and maximum displacement nodes. We called it antinodes. Okay, zero displacement mean nodes, and the maximum displacement mean antinodes. So this phenomenon basically the fundamental of the acoustic and form of the basic of sound production in many musical instruments such as flutes, clarinets, and organ pipes basically. So in the MATLAB basically we have just developed the standing waves under different boundary conditions in which we called it open and open closed tubes. The simulation basically calculates the exact resonant frequency wavelength with the harmonic patterns based on speed of sound and the tube length. So in the mathematical expression, we have just used the displacement and pressure variations according to the graphical and animated visualization of wave behavior for different various, we called it harmonics. Okay, so let me just check it. Keywords added, introduction is here, like how we check the stationary patterns according to zero displacement as well as a maximum displacement. And zero displacement means nodes, and then antinodes, maximum displacement. Then these are the standing wave in air columns. Okay, so standing waves according to the operation of sinusoidal waves. Okay, just a second. Axial precision, yes, basically this is standing wave. Okay, the objective and scopes, and yes, basically I have just added the complete, it's the MATLAB functionality in terms of tube length, speed of sound, frequency, wavelength, harmonic, number, and okay. Problem statement is here, methodology is here, and then the harmonic waves of wavelength, frequency, displacement according to the temperature of according to the standing waves parameters. Okay, the MATLAB design, simulation, and analysis basically is here, which is basically standing waves in closed tubes according to the different frequency and the harmonic signals. Okay, these are the output results for the standing wave tube harmonic signals, and then these are the standing wave in closed tubes. Okay, in the different frequency levels. These are the output results of open tube with the frequency of 171.5 Hz. Okay, we can just select the frequency with the harmonic signals as well. Okay, and we can also check the open and closed tube through GUI platform. Let me also show you how we can check the, for example, in 99 simulation, we can just open these all of these MATLAB files. For example, in here we can just run. Okay, I think numerically letters added in the. Okay, we can just run first it this one. Let me just a second. Just a second. Let me just also change the name. Maybe it will work, because with the frequency of okay, Now it will works. For example, in here, yes, let me just show you here, which is basically we can, this is the GUI, we can select the harmonics in the length and the close and open. For example, update, this is a closed loop, this is a MATLAB simulation of the GUI model, and we can just change the tube length in terms of here harmonic signals is maximum and close update. Okay, so tube length in let me also run this with the open tube. The harmonic 0 and the length of tube is here. Okay, so these are the MATLAB GUI platform. Then you need to run this simulation, standing waves open and close. See this open harmonic signals with the different displacement amplitude. Okay, and next one is basically this is, for example, it is in running condition. Let me just close it for the okay. Next we need to run this section. For example, this is a standing waves. Okay, these are the standing waves for the closed loop tubes. Okay, and these are the frequency of standing waves for automated closed tube with the frequency of 428.8 Hz, and how pressure variation and displacement variation changes the uh, position along the tube and its output graph. Okay, so these are the output results. You just need to check it, and if you need to ask anything, you just ask me. I will answer your all the questions. Okay, thank you.